Let us begin today's meet. Up till now, we discussed refraction of monochromatic light. We considered a light which is getting refracted to be of single wavelength. We studied diffraction at single refracting surface, single optical interface which separates two optical media of different densities. But along the path, it may suffer a series of number of refractions every time. All interfaces may be plane. In the most simple case, let us consider refraction of light along its path minimum 2 times. Let both the surfaces to be plane. For example, the best example is passage of ray of light through glass chip. So here, if you consider glass chip, it has two surfaces, upper one and this is the lower one. Suppose ray is incident on upper surface, interface is transparent, the other medium is transparent. So light will enter this glass. The again other surface is transparent, so light will emerge out of glass. So this is the case of ray of light suffering two refractions at two different plane surfaces which are parallel to each other. If both the surfaces are parallel, angle of inclination between them is 0, then it is proved and observed emergent ray and incident ray are parallel to each other. Emergent ray is parallel to incident but not along the same line of action as that of incident, but gets a little laterally shift. This is called laterally shifting. It is given on page 171 of the textbook. उसमें एक डायग्राम दी हुई है, लेकिन वो डायग्राम में उनने जो इंसिडेंट रे है इट इज नॉट, दे हैव नॉट कंसिडर्ड इज मोनोक्रोमेटिक. हम लोग मोनोक्रोमेटिक के बारे में बात कर रहे हैं. So both these will be parallel, but emergent a little bit will get laterally shifted with respect to incident ray. This is its property. We can also study double refraction considering two surfaces, both are plane in nature but not kept parallel to each other. Instead, they are kept inclined to each other. So the refracting surfaces make some non-zero angle between them, like this. This is angle of refraction. So you can study double refraction of one ray of monochromatic light again at two plane different surfaces but kept inclined with respect to each other. The best device used to study double refraction at plane surfaces inclined is this prism. ये prism है, मेरे हाथ में आप लोगों को दिखाई देगा. प्रिज्म आप सबको मालूम है. इट इज अ ट्रांसपेरेंट बाउंडेड मीडियम, बाउंडेड है, नॉट ओपन. इट हैज 5 फेसेस. ये ट्रायंगुलर दिख रही है सामने वाली, ये पीछे वाली. 2 ट्रायंगुलर which are called upper surface and lower surface. Other 3 are rectangular. ये रेक्टेंगल दिख रहा है, 1 2 3 4, 1 2 और ये वाली 3rd. So prism is optical bounded medium bounded by 5 inner surfaces. Out of 5, 2 are triangular and identical, which are called lower surface and upper surface. Rest 3 are rectangular in nature. Now I am focusing on the diagram which I have drawn on the board. Look at the board. बोर्ड के ऊपर देखो मैंने एक डायग्राम ड्रॉ की है, आप लोगों को इधर ध्यान देना है। It seems everybody is able to see the diagram. सबको डायग्राम दिखाई दे रही है। ये ऐसी डायग्राम है। I have labeled it as x, y, z, one triangular surface. X dash, y dash, z dash, the another triangular surfaces. These two are upper and lower, and prism is generally kept with one of the triangular faces touching the tabletop or the ground. ट्रायंगुलर सरफेस के ऊपर ये ऐसा खड़ा किया जाता है, like this. One of the surfaces on the ground and other surface facing towards the sky. Then out of these three, 1, 2, 3. डायग्राम मेरे को लगता है सब लोग देख पा रहे हैं। आई एम ट्राइंग माई लेवल बेस्ट फॉर द एडजस्टमेंट्स। वेट फॉर अ व्हाइल। अभी देखो दिखाई दे रही है क्या ठीक से? यू कैन नाउ सी वेरी नाइसली दिस डायग्राम। सो दिस इज वन फेस, x, z, z dash, x dash, one of the rectangular face. Second is x, y, y dash and z dash, another one. And third rectangular surface is y, z, z dash and y dash. So three rectangular surfaces. Out of three, one is made opaque. एक सरफेस को ओपेक किया जाता है, नहीं तो हम लोगों को आउट ऑफ थ्री वन सरफेस ओपेक है ये एज्यूम करना है। दैट ओपेक सरफेस इज कॉल्ड एज बेस। सो इन डायग्राम z, z dash, y dash and y I have considered as base. So only two left and both these are transparent for light. ऐसे हम लोग assume करेंगे। So what are the refracting plane surfaces? X, Z, Z dash, X dash, and another is X, Y, Y dash and X dash. I have shown it over here. इसके बारे में देखो, ये ट्रायंगुलर है, ये ट्रायंगुलर है, अपर एंड लोअर। दिस इज वन रेक्टेंगल, दिस इज अनदर रेक्टेंगल एंड पीछे वाला रेक्टेंगल है ये वाला, पीछे वाला उसको मैंने बेस एज्यूम किया है। इट इज नॉट ट्रांसपेरेंट फॉर लाइट। इफ लाइट इज इंसिडेंट ऑन इट, पीछे से लाइट आती है तो अंदर नहीं घुस सकती, और अंदर से अगर ये बाजू लाइट जाती है बेस के ऊपर, ये इधर आई और इधर बेस के ऊपर गिरी, तो बेस से वो बाहर नहीं निकल पाएगी। इट इज कंसिडर्ड ओपेक। These two refracting surfaces, rectangular in nature, are inclined at certain angles. This is called angle of prism. And these two refracting surfaces meet each other at one common edge. It is called refracting edge of the prism. हाँ, ये सब आप लोगों को ध्यान रखना है। So I am talking about to study to trace the path of ray of light through prism, and it is given as point number 172 पेज ओपन करो। On page 172, focus on diagram 9.18। 9.18 वाली डायग्राम देखो, उसकी जो सब दिया हुआ है ना वो यही है, मैं खाली बोल रही हूँ। So if you cut it horizontally, horizontal हम लोगों ने perpendicular to this refracting edge prism को कट किया, तो ये जो सेक्शन है एक्सपोज हुआ उसको बोलते हैं प्रिंसिपल सेक्शन। So A, B, C we will consider as a principal section which I have drawn on the board. अभी बोर्ड के ऊपर ध्यान दो, मैं थोड़ा सेट करती हूँ। ये वाला आप लोग देख रहे हैं, दिस इज एज। सो व्हाट इज इट? एक्चुअली व्हाट इज इट? This base segment BC represents this entire rectangular surface. उसका हमने सेक्शन लिया है ना. Then this line represents entire this subject. This segment represents entire rectangular surface z dash x dash x z. This segment represents entire reflecting rectangular surface x dash y and x. So this is called principal section. Light will incident at any point on this one refracting edge. कभी कहीं भी गिर सकता है. मैंने डालती हूँ आपको एक मैं डायग्राम बताती हूँ. ये हमारा प्रिज्म है. एवरी टाइम 3 डायमेंशनल डायग्राम ड्रॉ करना मुश्किल है. So for our convenience, what we prefer, we never draw 3 डायमेंशनल डायग्राम. ये जो बेस हुआ ना पूरा नीचे वाला 3 ऐसी डायग्राम हम लोग नहीं निकालते. ये एक साइड है, ये दूसरी साइड है. ये साइड पे एक रे आ गिरता है at any point anywhere on this surface. But this entire surface we will represent with segment AC. This entire another refracting surface on the other side we will represent by refracting side segment AB. So these are the representations and we will consider principal section of prism for further discussion. हम लोग उसका प्रिंसिपल सेक्शन ले लेते हैं. हाँ, तो इन each segment of principal section represents entire rectangular side of out of 3. ये base opaque है and 2 these are refracting. So we will consider principal section A, B, C of the prism where AB and AC are refracting surfaces while BC is made opaque, which is a base. It is opaque for light. We will select a ray incident on first refracting face AB. Suppose at point Q एक रे है Q पॉइंट पे ये सरफेस पे गिरा है. ये सरफेस है ना पूरा. ये सरफेस पे मैंने एक पॉइंट कौन सा भी तो चूज किया है, उसके ऊपर ये रे आके गिरा. So what is done? We will draw normal to the surface separating two media at the point of incidence. So this will give you angle of incidence I. जो नेम्स बुक में दिए हैं वही नेम मैंने डायग्राम में डाले हैं. तो आप लोग बुक भी रिफर कर सकते हैं. डायग्राम नंबर 9.18 ऑन पेज नंबर 172. 172 के ऊपर देखो डायग्राम 9.18. Path of ray of light through prism. Deviation means what? When it emerges out of the prism, it will change its direction. That is called deviation. So what will happen? This ray will cross the interface and enter the material of prism. Prism generally is made up of glass, but you can make liquid prisms also. हम लोग क्या करते हैं, उसको हॉलो बनाते हैं, अंदर से हॉलो बनाते हैं और एक इधर ओपनिंग रखते हैं. यू कैन pour लिक्विड इनसाइड दैट प्रिज्म. हॉलो प्रिज्म हम लोग लिक्विड प्रिज्म भी बना सकते हैं. जनरली इट इज मेड अप ऑफ ग्लास लाइक दिस. ये ग्लास का पूरा हुआ है, पूरा रिजिड है और अंदर से पूरी ग्लास है बिकॉज ग्लास इज अ ट्रांसपेरेंट मीडियम फॉर लाइट. लेकिन लिक्विड प्रिज्म भी अवेलेबल है. For instance, we will consider the prism under consideration made up of glass. तो क्या होएगा, ये अंदर आएगा, but changes the medium and it is moving from rarer to denser. So instead of moving along the initial same direction, it will bend a little towards normal. ये MN normal है, वो ऐसा आगे नहीं जाएगा, थोड़ा सा मुड़ के जाएगा. Since moving from rarer to denser, it will bend towards the normal. It will not follow the initial incident path. So QR is a refracted ray. From inside, it will incident on second refracting surface AC at point R. Again, the interface is transparent for light, so it will emerge out. Now, this will be its original direction. Refracted ray की direction ये है, लेकिन क्या होता है, मीडियम चेंज हो रहा है, so definitely it will not follow this direction of initial refracted ray. इंसिडेंट रे को अभी भूल जाओ, इंसिडेंट का रिफ्रैक्टेड हो गया है, अभी रिफ्रैक्टेड आगे जाने वाला है. So, but it will not proceed in the same direction. Instead, when goes from denser to rarer, it will bend away from normal. So, this is the another normal M dash N drawn to surface AC at point R. And instead of moving this like this, it will bend a little away from normal. So, this R2 is less than this E. R2 and E same नहीं होंगे. I and R1 angle of refraction at the first refraction दोनों will be different. I will be greater than R1, but in this case E will be greater than R2 because it is emerging out along RS in air from glass. So what is the direction of emergent ray through prism? Along RS. So PQ is called incident ray, QR is called refracted ray, and RS is called emergent ray. So when ray comes out of prism, emerges out of this refracting medium, this will be its final direction. So through which angle it has changed its direction, it's called angle of deviation. To find it, what we will do? We will extend incident ray in forward direction, that is PQX T, and emergent ray in backward direction. So angle between these two, क्या angle है ना? वो क्या रहेगा? The angle through which it has changed its direction when emerges out of prism. This is called angle of deviation. So you will get this diagram. Again, you have to show base. You have to show two refracting surfaces. Angle between refracting surfaces is called angle of prism. Incident ray PQ making angle of incidence I when incident at point Q on face AB gets refracted, moves along QR, which is refracted ray through prism, incident at point R from inside the prism on second refracting surface AC and emerges out along RS. So arrows are necessary. उसकी डायरेक्शन हम लोगों को दिखानी है, तो हर एक रे के ऊपर एरोज चाहिए. तो हियर व्हाट वी विल गेट? Angle A, angle I, angle of emergence E, angle of deviation delta, two more angle of first refraction at first refraction, angle of refraction R2 at second refraction. So you get all these different terms related to this figure, and using geometry you can relate these terms. ये सब जो सब terms नए नए इन्वॉल्व हुए हैं ना, वो हम लोग रिलेशन में मैथमेटिकली उनको बांध सकते हैं. दैट इज कॉल्ड एनालिटिकल ट्रीटमेंट. सो यूजिंग फ्यू ज्योमेट्री कंसेप्ट्स, यूजिंग दिस ज्योमेट्रिकल कंस्ट्रक्शन, वी कैन हैव द रिलेशन बिटवीन डिफरेंट एंगल्स A, I, E, R, delta, R1 and R2. And that derivation is given on page 172 below the diagram figure 9.18. जो मैंने बोला वही बुक में दिया है. अगर बोर्ड आप लोगों को ठीक से दिखाई नहीं दे रहा है तो आप लोग बुक में से ज्वाइन कर सकते हैं, देख सकते हैं. So when we use geometry, we get relation a plus delta is equal to I plus e. This relation I will prove on next day. Next time मैं वो prove करूँगी. Next time prove करूँगी. And hence, and other relation we get a is equal to r1 plus I. So using geometry, we get these two derivations. I will do it next time. Only I will continue. So if r changes, ये जब भी एंगल ऑफ इंसिडेंस आए तभी ये बात होगा. अभी मैंने एंगल ऑफ इंसिडेंस चेंज किया. If I make it I2, ये एंगल मैंने I2 किया. तो E की वैल्यू E2 हो जाएगी, R1 R2 की वैल्यूज भी चेंज हो जाएगी. So if I is changed, value of E and hence delta also changes. So delta depends on angle of incidence R. So what we have to do, we have to take one prism and we have to draw different diagrams by taking value of R starting from 0. पहले R 0 लेना है, then 10, 20, 30, 40 आगे आगे gradually increase करके जाना है and we have to find corresponding values of delta. It is experimentally proved. ये experiment हम लोगों को करना है practical के time. So we will perform it. So what happens here? Initially, if R increases gradually from 0 to large values, delta initially increases. For first small value 10, 20, 30, delta is large. Then as I increases, it decreases. It attains some minimum value which is called angle of minimum deviation, delta N. And after I giving value of delta N is still further increased, then it starts increasing continuously. So the nature of graph of delta versus R is unknown. So for one particular value of R, delta has value delta N. It is only possible where this R and E are equal. एक स्टेज आती है, R चेंज किया तो delta चेंज होगा और E भी चेंज होगा. लेकिन at one particular value of R, it becomes E. And that time delta has minimum value. It is experimentally proved and we are going to find delta N for your material during experiment, during practical. So what is the condition? When delta is equal to delta N, using this graph निकालना पड़ेगा हम लोगों को. So that time I has one value, one particular value, it matches with angle of emergence E. So this is the condition. Say condition. Agar and that time when R is equal to E, it is proved R1 also becomes equal to R2. जब ये R2 की वैल्यू E के बराबर होती है ना, तभी R1 और R2 के वैल्यूज भी सेम होते हैं. So using these two, using Snell's law क्या है? Refracting index of medium of glass with respect to क्या आएगा? And will be sin R upon sin R. And you can find R. A plus delta M by 2 because I is E. So 2I will be A plus delta M. I will be A plus delta M by 2. So I will be A plus delta M by 2. And here R1 plus R2 will be 2R. Both will be equal. That will be A. So R will be A by 2. So finally you will get refractive index of prism with respect to air. Material of prism will be sin A plus delta M by 2 upon sin A by 2, which is called as Prism formula. So today we derive the equation, the relation for Prism formula. So in next lecture I will give you the proof for this too. Before winding, I just want to make announcement. I am going to give you one assignment for the Diwali homework. Everyone has to solve that assignment and you have to submit that assignment after Diwali. तो ये जो असाइनमेंट में दूंगी ना, समरी वाली जो हम लोगों ने अब तक सीखा है, वो हम लोगों को separate pages पे solve करनी है and you have to submit it after Diwali. So everyone will solve the assignment on the separate papers and will submit after Diwali. So today we have completed the derivation for Prism and closing will be